My name is Sarah Coughlin and I'm in the Newcrest HVAC lab at the University of Queensland, and in the next few minutes I'm going to go through the ducted fan prac for the fluid mechanics course in mining. First we're going to go through the setup of the components that comprise the duct. The components of the duct are this orifice plate, a straightener for the air, a fan, an axial fan, and an aperture device at the outlet. There are 4 sensors that are used in this duct. The first is a pressure sensor right at the start of the duct. The next is a temperature sensor for the density. These next two are also pressure sensors that measure the difference over the fan. Initially, we take the atmospheric pressure and the pressure that's taken by this sensor here just within the orifice plate to determine the initial airflow through the tube. Next, the air is straightened through the straightener. It passes through the fan, and the airflow can be varied by adjusting this aperture device on the outlet of the tube. The data that is recorded from all of the sensors in the duct is taken and put into a software package that's on the computer. I'll now go through with you how the software works and to make sure that you're recording data correctly. To open the program, first go to Start, All Programs. It's called ARM Field Capture Software, and you want this first one that says Axial Fan. When it initially opens, it will actually look like this and have a set of instructions. If you're not sure what to do still after watching this, feel free to have a read. Otherwise, click on this icon here, which will bring up a setup that we just went through that's on the table. On the left-hand side here, there are a number of different parameters that we can set. The first is sample number, which records how many sets of data you've currently taken. It says 1 because we haven't recorded any yet. This would be our first set. The next is atmospheric pressure, which I spoke about before, which determines the pressure change across the orifice plate and is used to calculate density. If you click on it here, you can edit it. If you Google UQ weather, you can click on the first link, which comes up with this page. This reading here is the one that we want. It's currently in hectopascals and we want kilopascals, so you have to change the decimals a little bit. So currently we have 101.7. So if we put 101.7 in here. Next is the orifice plate setting, which we don't modify because it's calibrated for the duct as it's set up as it is. Here we have the fan speed and the flow rate, which is calculated after we turn the fan on. We don't modify that either. These 2 settings down here are controlling whether the fan is on or off, and the speed of the fan. The speed of the fan is set as a percentage, so we're going to work with 3 different fan speeds at 40%, 60% and 100%. Currently we've got this set at 40. If I change this by clicking on it, it turns into a 1 and the fan is going. In this diagram there are 4 values that are being recorded. Temperature at the top is the temperature that is recorded by the temperature sensor in the duct, and currently it's at 28.1. Motor power is the power that's being produced by the fan. This pressure here is the variation across the fan, and this pressure here is just downstream of the orifice plate, which is used combined with the atmospheric pressure to determine the initial flow rate through the duct. To collect data using this software, you turn the fan on at the speed that you want, and you can observe that this pressure changes. You wait, they'll go up, and then you have to wait for them to stabilize. They're not going to stay exactly the same, but they level out roughly. Once you've got them once they've leveled out, you press go to record the data. Once you've pressed go and you go back and click on this Excel document, you have sample number 1 and this data that you've recorded for the diameter fully open and the fan speed at 40. So now what we can do So we need to go back to here, we need to turn the fan off, and we change the diameter of the aperture at the outlet of the device. So, if we look at this, we just close it a small amount, and we tighten these up. Then we go back to the computer software, and we turn the fan on again. Wait for the pressures to stabilize again. Press go once more. Check our data in the Excel document. We now have 2. You repeat this process for 6 different diameters. So you need to adjust the diameter at the end of the duct 6 times, and your smallest diameter must be no more than this. This is as small as you need to make the diameter. If you make it any smaller, the software doesn't recognize any pressure at all. With an open diameter, you come back to the software and you change the speed of the fan to 60. Here, you turn the fan back on, wait for it to stabilize again, collect more data. This spreadsheet in the end will have 18 samples in it, 6 for each different speed. So after you've done 6 different diameters at 60%, you change it to 100% and complete the process. When you have this spreadsheet full, you can save it and email it to those members that did it with you, and that is the Prac finished. After you've completed the Prac, you need to write a report at home. There are 2 graphs which are unique to this Prac that must go in it. I'm going to go through those 2 graphs and how you create them now. This is the first graph that you'll be creating. These are your 18 samples that you collected. For 3 different speeds, you simply have to plot them, the change in the pressure over the flow rate. This data is in the spreadsheet that you've got. Once you plot this, that's 1 graph completed. The next graph you have to make is non-dimensional. So that means we have to get rid of the units for pressure and flow rate, and to do that, we use these 2 equations here for psi and phi, which are the head coefficient and the flow coefficient. If you put in the values for the change in the pressure, the density, the frequency, which is the speed of the fan, and the diameter of the duct, which is 123 millimeters, you'll calculate the head coefficient. This is the flow rate over the frequency, speed of the fan, and the diameter of the duct. And these 2 values don't have any dimensions. From the pre-work, you actually calculate why they don't have any dimensions. You need to put that in your report as well. But if you plot psi versus phi, you get 1 curve for all your data, not 3 different ones. They all fit. It's not going to be extremely accurate, but they should all fit on 1 curve, and you fit a line of best fit to that curve. You have to describe both of the graphs and talk about the effects and analyse it and all that kind of thing like a normal report, but they're the 2 graphs that you need to include in your report. Good luck completing the Prac and writing the report. If you have any questions in the Prac, address them to your tutor, or watch the movie again, or read the instructions that are in the software. Hopefully you can figure it out.